That's the edge of that, so let's do there. There we go. Okay. See what that's like.
All right, so first couple things, a couple announcements. That can never be good news, right?
Yeah.
You got that right. So it's a quiz. Thursday on chapter 1, and then quiz next Tuesday on 2, 2, and 2, 3. All right, so hopefully you all have copies of or access to the Chapter 1 homework now. The book, you have the links I gave you to the chapter, so you can do Chapter 1 homework. Chapter 2 we're going to finish up, 2.2 and 2.3 we're going to finish that up today. Normally the way I do quizzes is the day that the homework would be due. Remember, whenever we do a section, 2 class periods later, the homework is kind of due. I say like this because it's not really definitely due until the day of the test. That's when I do quizzes. So I'll never do a quiz the class after I discuss something. Does that make sense? I won't have that material on the next class because I want to give you that class in between to ask questions about homework. So, any questions on chapter 1? Yeah.
16.
Number 60?
16. It's 1.2.
1.2, number 16,
Please.
Oh, so what's it mean for, how could you tell, and there's a problem like this in section 1.3, I think. What kind of company should not sponsor the research if they're trying to show that there is no link between candy and obesity?
Candy company?
Candy company. Does it automatically mean that the data is bad?
No.
They could have totally done it totally fine, no problem. But since they're actually hired the person to do the study, you automatically say to yourself, I can't really trust that. What kind of entities do we hope we can trust? So this problem is asking about the Federal Trade Commission, right? Yeah, Federal Trade Commission. Measuring amounts of nicotine. What are the repercussions for the Federal Trade Commission if it's discovered that they falsified data? You think that they're kind of large? You think, yes. They want to be trusted. So do you think that their data would likely be unbiased then? Unbiased, yes. Right, so I would believe that the data coming out of the Federal Trade Commission is going to be unbiased. Because the day that somebody finds out and can prove that there's biased data coming from them, they're shut down. What the hell can they do? You can't trust anything coming out of there anymore. So they can't let that happen, so it must be all above board. Does that make sense? If it was Philip Morris sponsoring a study, hired somebody to do a study on nicotine levels and so forth, could we trust that data? Would we believe it to be unbiased? No. It sounds to me like we'd have to assume it's biased, right? Are you guys kind of with? I mean, that's kind of basic stuff. When I say Federal Trade Commission, you might not know what the hell that really is. Federal, though, so it's a part of the federal government, then that's the kind of thought process you go with. Any other questions? Yeah?
Any differences on section 1.2?
Oh yeah, this is good. This one talks about statistically significant data findings. So this was about surgery versus splints. And the very first thing I want you guys to realize, if you're comparing two groups of people, like you want to see, does this medicine affect men differently than it affects women? Do they really have to be exactly the same size samples of men and women? No. as long as you're reporting percentages, you're fine. Is everybody cool with that? It seems to me that people understand percentages less and less. And in this class, you really have to understand percentages very well, right? So a percentage takes out that one place is bigger than the other. I love it when somebody has a study and says, oh, there are a lot more murders that happen in California. I'm not going to go, there's a lot more freaking people in California than other states. They're the 7th largest economy in the world, so I mean, it's a pretty damn big state. So you have to talk about either percentages, or very often you see out of 1,000. Or something, out of 100 to make it out of 1,000. You guys with me?
Mm-hmm.
Okay, maybe. So the fact that there's 73 with surgery and 83 with splints, that should not show up in any of your answers. They didn't have the same sample size, so they're all, no, they're fine. They don't have to have the same sample size. 92% success rate. Among 83 patients with splints, there's a 72% success rate. We haven't learned the math yet to really tell when things are statistically significant or not, but this is pretty blatant. How large of a difference is there between splints and surgery? 20% difference, right? That's huge. If it was a 5% difference, then it'd be like, I don't know if that's big enough or not to be statistically significant. But they go further, just to make sure that we don't say, well, we haven't learned enough to do this problem, which I haven't seen anybody say yet, but you never know. It does say, calculations using those results that we will be doing later this semester showed that if there really is no difference, then there's about a 1 chance in 1,000 of getting success rates like the ones obtained in the study. So let me talk about this, because this is huge for the rest of the semester. Remember what I was talking about randomly. I could go out, randomly select 20 people, and it could be that they all have an average age of 70. You with me? Is that likely? So, if I go out right now and I select a random group of people and it turns out the average age is 70, that's evidence that the average age of students at Grossmont is higher than they claim. Because what's more likely? That they're lying about the average age of Grossmont of students, or that I randomly selected 20 people that were age 70 or older? It's more likely that they're wrong about the average age. So here, this is the key. They did a study, and they got a 20% difference between success rate for splints, success rate for surgery. And they said, if there really was no difference, there's a 1 chance out of 1,000 that we would have randomly selected samples that would show that big of a difference. You guys with me? Let me say that again. If there really was no difference, then to go out and randomly select a sample of surgery people and a sample of splint people and have that big of a difference randomly would only occur 1 out of 1,000 times. So what's more likely? That there really is a difference in the success rates, or that we randomly selected them that there was such a big difference in the samples? There's probably truly a difference in the success rates. How are we doing here so far? So the concept I want you to grasp, we're going to back that up with a bunch of math later in the semester. We're actually going to be able to do these studies ourselves and actually calculate the probabilities of success rate being because of this or because there really is a success difference, right? Okay, maybe. So that's what they mean when they tell me there's a 1 out of 1,000 chance that this occurred randomly. What they're really saying is there truly is a difference in the success rate. So that's statistical significance. It is significantly more likely that there really is a difference than I just randomly selected a sample that showed me this. Cool? So for example, if you feel that M&Ms, what's your favorite color M&M?
Green.
Green. So you feel that they're skimping on green. You're like, those bastards. I open up my bag and there's like 2 greens in there. So you do a study and you say, they claim that like 20% of M&Ms is green. So you do a study. If you get a lot of M&Ms and you show that only 10%, and you got a lot of M&Ms, only 10% of every bag I opened up, that's statistically significant. Because what's more likely? That you just happen to randomly pick bags, you're really unlucky, the universe has it out for you? or that they really are putting less green in there than they say. What's more likely is they're putting less green in there than they say. How we doing? Okay. So for this question, I know I go off on these huge, I was trying to prepare you. 26A. Should we conclude that surgery is better than splints from this data? Yes. Cool. Now, if somebody else didn't believe this, what would they do? Do another study. Right? If you didn't believe this, then you would do another study. And then you would do another study. And then you would do another study. And that's how science works, isn't it? You always hear that's what people's big complaint about it is, well, one day it was bad to eat eggs, and the next day it's good. That's because they put studies out too early, before other people have a chance to confirm what they've seen. The big thing about science is you have to be able to repeat it, right? They do it over there, we better be able to do it over here. That's the whole thing about cold fusion. Everybody knows about. Of course, what the hell's that? Look up cold fusion. You'll see that. Does the result have statistical significance? Yes. It's so unlikely that it just randomly happened that it is statistically significant. And here's what I love. Does the result have practical significance?
I said no.
So why do you say no?
Because the invasive surgery might not be worth the extra 20%.
So I would accept two different answers here. So no, I understand. In fact, personally, I would say no, because it really is dependent on other factors that aren't in this study. You with me? Age of the patient, so forth. So it all depends on different factors that are not included in this study. If you said yes, because it points you to which to do, surgery or splints, that's actually the point they're trying to make. Is that you would say yes because it tells you what you should do. Practically, what should I do? I should do this over this because it's got a better success rate. But the no's I understand. And that's why I always ask you on a quiz, explain. I give you a chance to back up your answer. I'm not looking for just a yes or no. I'm looking for explain, and if you explain it well, I might give you full credit.
You mean number 3, is it yes or no is correct? Like
For 26C, I would accept either one because it goes beyond what this problem intends. There are other factors to consider individually, right? If I'm 80, it might not be good for me to go under for surgery because I might have other implications that might preclude that. I might want to go for splints even though it has a lower success rate. You with me? But there is statistically significant data saying that surgery is better than splints. So on the other hand, it's okay to say yes, yeah, it's got practical significance for some people. Okay, but that's the difference between statistical significance and practical significance. If it was statistically significant and they showed that 2% higher success rate, and that's statistically significant, is that practically significant? No. It's like a 2% increase. That's not big enough for me to worry about. Yeah?
So when you do something like a practical significance question, it's okay to consider those kind of variables, like they're old or it might be too invasive.
That's the thing that I don't like about this, because actually the answer that they have in the solutions manual is yes for that.
So
It's always bothered me, because the main thing here is they didn't include all the other variables. So remind me, who watches Mythbusters? Who amongst you might now start looking that up and start watching it because you know I'm going to start referencing it? They do an excellent job on the show of talking about controlling variables, right? So if there's a possibility that age would have something to do with the results, then what you do is you get a lot of people that are in the same age range. So you've controlled for that variable. And then you see the difference between surgery and splints. You with me? So then your population won't be everybody that had surgery or splints. It'll be this age group that had surgery, this age group that had, so you can see the effect of age on things. Yeah, and they didn't talk about that in this problem, so I'm glad some of you guys thought to bring that up. Finally, Part D, should surgery be the recommended treatment for carpal tunnel syndrome? And again, it kind of depends on your answer to Part C. If the answer to Part C was yes, then D, yes. You should recommend it because it says statistically significantly that it's got higher success rates. Or you could argue, well, it depends on the person. If you're old, if you have pre-existing medical conditions, whatever, surgery might not be the better way to go. Yeah.
I said along with the high risk, if it has high risk of complications, I also said it should just lot more costly to do the
True,
surgery.
exactly. They didn't bring into play the.
$4,000 to do this, or it's $40 to put a
Exactly. Exactly. And that's the other side of practical significance. Is it really worth the extra money in this case? And they didn't bring up money at all. It's near and dear to my heart because my dog had to have surgery on both her knees. And there were 3 different levels of surgery. And one of them had a lower rate of success, but it was only this much money. You know, and I'm like, well, why would I do anything if it's most likely that they'll bust out again? What the hell? So we found some help to do the higher level surgery for her, and she's doing okay right now. Okay, so any other questions on that one? Yeah.
Oh, no, no.
Any other ones on that one before All right, so which one again?
I have 2 questions on 1.4, 12 and number
1.4? All right, so 12 is asking, is it a statistic or a parameter? And this is one of the ones, I don't think I mentioned these in class, so it's part of the reading. But what's the beautiful thing about statistic and parameter is the first letters. Because who knows, a parameter describes a numerical measurement of a PP, parameter of population. Statistic describes a. All right, that's awesome. That doesn't happen often enough in math, right? The letters go together, you know which one it is.
Are we at 1.3 or 1.4?
Shoot! I do that.
Okay.
But I'm glad I said that because now we're all on the same page with that. So 1.4?
Yeah.
Oh yeah, so 12 is a weird one. I'm glad you're asking me about that one. A lot of people answer the question by saying they didn't say that many what. And that's not really what the question is getting at. So it's obvious that it would be about the number of people in America. So what's wrong with them saying 281,421,906 people in America?
Should have been an approximation.
Should have been an approximation.
That's not the exact total of people.
Exactly.
In the country.
Way too precise. Because even the second the census is done, what happened?
Population went over.
Somebody else was born.
died.
Or 20 other people were born, right? Where are we at right now? Does anybody know where we at population-wise in America? 310. I remember the day, it was October last year, I think, that we passed 300, was it last year? We passed 300 million. And we're already up to 310 million. We'll all be living, standing on each other's shoulders. Which was the other one? 12 and 20? Oh, yeah. So, unfortunately, a lot of the problems in this book are a little morbid, a little depressing. So this one's about sudden infant death syndrome. And they said, there was a statement that said, putting infants in the supine position has decreased deaths from SIDS. And this is lying on the back with the face up. She suggested in the statement, pediatricians advised the supine position during a time when the SIDS rate fell. What is wrong with saying that the supine position decreased death from SIDS? So they did a study and they saw that if the supine position was used more often, the death rate went down. Now I kind of just said it in a way that suggests that there's a definite order. So let me give you an example. Let's see if we can come up with one real quick. Crap. I can't come up with one. So what this is saying is, if, for example, here's a really good example, fun. Some sports player, and some of you guys who play sports have done this, I know, because I've done this myself. There's certain socks you wore and you won a game, and then you happen to wear the same socks and you won another game. And you said, holy shit, those are my game-winning socks. If I don't wear those, and we all know that every player has a different thing. Well, I did this once and I won the game, so now I got to do this thing every time. And it becomes this huge ritual, right? What's more likely, and not to step on anybody's belief system, but what's more likely happening? You would have won that game no matter what the hell you did. Or you could have focused on something else. You happened to wake wake up and go with the left side of the bed instead of the right side that morning. You could, and then that could have been your. Oh, that's what it was. Not the socks. The socks. That's stupid. It must be the side of the bed. That makes more sense. So just at the same time. So for this problem, at the time that SIDS was decreasing, the pediatrician said you should do the supine position. So does that mean that one caused the other?
No.
No, it just happened at the same time. So often, and remember, that was my pet peeve. Misinterpreting correlations. This caused this because this happened and this, and no, it could have happened no matter what the hell you did. Right? Well, I prayed for an A really hard and then I got one. That must know. Right? I don't think if there is a deity up there that's going, well, he wants an A really bad. It's an A. Right? You could have done anything. Right? Yeah.
So correlation does not imply causation.
Exactly. Correlation does not imply causality. Right? Just because I see a relationship between two things doesn't mean that one caused the other. Because if there is, I don't know which way it goes. Did this cause this or did this cause this? Egg, chicken? I don't know. Right? And the other thing, maybe they're both caused by something else that I don't even think about.
Two different things.
Or they just happen to be happening at the same time. Right? I jump in the air and somebody over there falls over. I'm like, I have powers. Weird power to have. Obviously, my example creating part of my brain is still asleep. So I'm sorry about that. Any other questions? Yeah.
4?
On 1-4?
Yes.
Oh, they're going to do this to you a lot of the time in the book. So this should be a quick question, a quick answer for the rest of the book. Because they're kind of evil this way. Typical surveys involve 500 to 2,000 people. This person, she based her conclusions on a sample of 4,500 replies that she received after mailing 100,000 questionnaires. So you see how they set you up for failure here in a way. They tell you that normally surveys are 500 to 2,000 people, and then they say, well, this is 4,500. So are her conclusions likely to be valid?
No.
Well, there's a huge sample. What's wrong?
They're voluntary response.
Yeah, it's voluntary response sample, right? She sent out these questionnaires. The people that return them are most likely to be biased, possibly one way more than the other. So you can't trust. I don't care how large it is. So later you're going to see something like, well, you included 8,000 people, but they were all your Facebook friends. Right? It's a huge sample, so can we trust it? No, it's your freaking Facebook friends. Automatically they're biased. They all know you somehow, so they automatically have some kind of bias that might affect the situation. How we doing? So don't let that problem, you're going to see that same question several times. Any other questions yet?
Just the second part of number 2, I wasn't sure if that was
The funny thing about number 2, are all voluntary response samples bad? No. You know, most all questions are no, you can't say it all the time. No, most of them will be bad, and in fact, if it is a voluntary response sample, I can't accept the results even though the sample might be good. You with me? So that's the unfortunate thing about statistics. You could do something poorly, like go pick a sample poorly. The sample could be good, but I can't trust your data because I don't know it's good. Or we could do everything by the book. We could put the list of all the people up on there, and I could have a lot of different people throwing darts, and I could pick those people, and it turns out that all those people are 70 years old. Randomly it could happen. But I'm going to trust that data more than I would trust the other one because they made sure that their sample was selected appropriately. Cool? So that was the first part. Your question was the second part. Are all bad samples voluntary response samples? No. You guys would be a bad sample if I'm trying to represent Grosse Pointe College, right? You wouldn't be voluntary response because I'd say, answer this question or you fail. That would be evil. So would you be voluntary response? No. But you're bad. You're actually called what? Who knows what the type of sample it is if I just take you guys as a sample because I'm tired and you're here. Convenience sample, right? You would be a convenience sample. That's also another example of a bad sample. So not all bad samples are voluntary response. Cool.
How about 15 and
15
17? And 17.
and 1-4?
Children, what for?
1-4. 15 gets people. Hawaii State Senate held hearings considering a law requiring that motorcyclists wear helmets. Some motorcyclists testified that they had not been in crashes. They're like, it's fine, I don't need a helmet. What's inherently biased about that? Who could not be represented there? Who was not able to be there?
Dead motorcycles.
People that died. So that's another, you start to realize, that the thing I want you to realize right now is how many ways data could end up not being trusted, right? Not being something you can really trust. So there, it sounds like everybody showed up today, said they were fine. They showed up because they survived.
Right.
Right? Inherently, there's a bias there. You guys with me? Mm-hmm. So that one's because of that. It's because the people that died or who are seriously injured somewhere laying in a hospital, they can't walk in there and say, I think it's all right. Right? Unless you're in a zombie movie or something. What was the other one? 17. Oh. Blah, blah, blah. If I add up the average income for all the states, I think this is basically what it's saying. I can't remember. If I add up all the income, all the average income, so I average up Florida's income for all the population, I average Georgia, I average New Mexico, and then I add them up and divide by 50. Why is that not the real average income?
Each state has a different population.
Each state has a different population. So actually each state's average should be weighted differently. And the idea of weighting is going to come up, not waiting for something to happen, but waiting, is going to come up later in this semester. You got to be real careful about how you average numbers. And I love it when I say, like, the problem where, this is going to sound familiar, you made an 80, a 72, and a 78. What do you have to make on the next test to average an 80? And what some people do is they average these three, and then they figure out what to average with that to make 80. And this is a weight of 3. That's got a weight of 3. There's 3 tests there, right? So you can't just average these and then see how far off what you need to make up. You guys with me? And that's sort of the mistake that's being made in this problem. One state has more people than another. You can't just treat those directly the same. Yes, sir?
Didn't you also say, they say the per capita income for all individuals, if it's all individuals, wouldn't that include children who aren't working?
Average per capita income for each of the 50 states. Yeah, I'm assuming in the background of this, it's the people that are of working age. Because another thing that people have brought up is, what about the people that don't have a job? Well, then their average income would be zero, so they would be included, right? But we can pretty much assume that it's those who could work. Yeah, but that's a good point to bring up because they didn't say. Okay. Yeah, one last question.
18.
In 1-4?
Yeah. Exactly.
All right, so this is almost done now. Actually. Oh, so I did this to you guys. I said enter your height in inches, and I've seen the results, and I have personally lived through the answer to this. What are 2 major problems with this request?
We're used to thinking about our height in feet and inches.
Okay, so some people don't know, to kind of piggyback what you're saying, don't know how to go from 5'8" to what that is in inches. So I did see a few entries of 5'3", 5'8". So I just made them into inches for my numerical purposes. What's the other possible problem?
People are more likely to plan what they want or their actual height versus what they think.
People could lie, and a question like height, weight, questions about sex, you always hear about these articles done about it. Very likely be lied on because you want to represent yourself in a certain way. The more anonymous you make it, and try to make sure that you understood that was anonymous, the more you hope you actually do get true data. Okay. And the other thing is, some people don't know how tall they are.
Yeah.
They just haven't, when you're a little kid, maybe your parents did the whole, you're there now, Timmy. No, you're there, Timmy. Well, you're there, what happened to you? You went backwards. But nowadays, it might be true that you haven't done your height in a while, right? If you're younger male especially, you don't go to the doctor very often. So I understand that. I've lived through that myself. So you don't know how the hell tall you are if it's been a while since you did your height. Okay. So, what I want to do today, I think if you guys will help me, I said this last time, could somebody remind me what the frequency distribution looked like that we ended up with last time? The frequency distribution? No, you don't. Just stay right there. Okay.
You're looking for the numbers?
Yeah. So it was we had the classes.
16 to 22. 23 to 29. 30 to 36. 37 to 43. And 44 to 50.
And then there was the
12.
frequency.
6, 2, 1, 1.
And then the relative frequency. Remember, to get the relative frequency, you add up these. 12 and 6 is 18, and 2 is 22. And then you take 12 divided by 22, and you make that into a percentage.
54.5.
54.5. This is 27 point something.
It's 27.
27?
And we had 9. 4.5. And 4.5.
Okay, because I don't think I got to the point where I actually made an histogram out of this, right? I think that's where I stopped off. So this is section 2.2. Here's section 2.3. And like I told you guys, do this homework together. Because 2.3 is going to refer you back to the tables you create in 2.2. So I wish they would have made one section out of it, but too bad for us. Be careful. So here comes your histogram. And I think we did talk about what you have to do with these numbers to make it show up there correctly. I don't want any gaps, right? So what was it that I had to introduce here to use as a scale?
You get an F's.
Yeah, go down by a half, up by a half, down by a half, up by a half. Okay, I think we get the idea, right? Who remembers what those were called?
Class.
Boundaries. And I often think of it, this is the limit of me. I don't exist out here. This is the limit of me, but I have my own personal boundary. Respect my boundaries, dude. Right? You can't come. So that's what I think. This is where the class really is. It's the class limit, but that's the class boundary. That's where it gets its comfort zone, right? You guys with me? Just help you remember, maybe. And I think I showed you the way that I used to do these, and you're certainly welcome to do it this way, because then you don't need limits or boundaries. It's all the same thing. Like that. There's no ambiguity then. The reason there's ambiguity here is because there's a big gap from 22 to 23. This has no gap. This goes up to 22.99999999999, and it starts over 23. There's no gap inherently. Either way you want to do it, this is the way the book does it. This is a less ambiguous way, but the book does it isn't there to back you up. So whichever way you want to do it is fine with me. So here, let me do it the book way. Who knows what this symbol here is? It's not a heart symbol. Not a little, I'm alive.
Skip forward.
Good, skip forward. It's like I'm breaking the scale for a second. There's nothing here, so I'm going to where there's something. I don't think the book really makes a point out of that, but always make sure there's a little bit of a distance there so I can see what's going on. Then I would start at 15.5. And then I just go up by 7 because that was our class width. So remember. You got everybody? Okay, that's it. Now, there's two options for this scale. The height of my bar should represent somehow the amount of things in there, right? The higher the bar, the more stuff there was. So I could either make a frequency histogram, or I could make a relative frequency histogram. And really all it is a difference in what numbers I use on the scale. So let's go ahead and make a relative frequency histogram.
Still look the same.
it would look exactly the same. The shape would be the same. It would just be, instead of 12 there, it'd be 54 and a half there. You know, and just go up there, it would still be the same shape. And that's what's important, really, is the shape. If I want to make relative frequency, how high do I have to be able to go? How high? Sound like my Frisbee? Yeah, I need to go up to this height. Now, please, dear God, don't do this 25, 50, and then you have all this space you don't use, and then it's really hard to tell what the hell's going on. You know, use a good, smart scale. If I need to go up to this, maybe by 10, 20, 30, 40, 50, 60. So my 54 and a half will be right there. The worst thing you can do on any graph, in math, science, wherever you're making a graph, is to not have a consistent scale. I'll often see somebody say 4.5, 9, 27, 54.5. All my pictures look about the same, Jim. Well, yeah, you're forcing it, the issue. Make sure they all fall somewhere, but your scale has to be consistent. Okay, cool. So how tall is this bar going to be? 54.5. 54.5. So it doesn't have to be perfect, just somewhere right in the middle there. And then the next one will be 27. The next one's 9. The last two are about half of that, 4.5. How are we doing? Isn't that basically the prediction I made? Or it's almost, and actually this is the prediction I made, I forgot. The one we're doing today together is about your heights, and I think on the quiz on next Tuesday, I'll do the one with your actual ages. Because there are still roughly 11 people that haven't done that survey yet. That was due today. So 42 people that have done those surveys. If you have not done them yet, go to the website. The first 2 links are to the surveys you need to do. Yeah.
I just did it this morning, and I had problems finding it because for whatever reason I didn't see it in the very top of the syllabus until this morning. Because I was looking all over the syllabus.
In fact, if you just do it by the end of the day, you're fine. Today's not over yet, so you got until the end of the day. Please try to get in there and do it if you haven't done it yet. I want to include everybody's data when I start making problems based on these data. Okay, so what we're going to do right now is a couple things. I'll let you kind of roll over this for a second. You read the first set of instructions there. The first thing I need to show you how to do is to use your calculator to sort data. So I did bring some calculators if you need to borrow one for today. Good, do good. Oh yeah. Last year I was in a room that had a very touchy, it didn't want to turn on no matter what the hell I did, so I was excited about being in a different room. It still wants to mess with me. So here is something very useful. I call it your calculator fighting. It's got all the procedures that we're going to be using this semester, but it also at the very top has this basic, how the hell do you use this thing? How many of you guys, remind me, have never used the TI-8384 before ever? Okay. See? Oh. You need to borrow one. They're up here. Come up and grab one. It's not going to be the same. Yeah, it's not going to be the same place. I might have run out. Yep, looks like it ran out. Okay. Oh, could you one that says whiteboard? There might be one that says whiteboard. Yeah. Is that you guys can see that, right? Maybe. Okay. So very quickly, just a few of you said you had never used this before. So let me just show you real quick. On buttons right there. Notice everything in blue on mine, and some of you guys it's yellow. You have to hit what I call the shift button, the second button. So if I want to turn it off, I have to hit second on to turn it off. Mine never turns off because it's not a real calculator. So if you want to hit something else, like you wanted for some reason to go, here's a really good button to know. If you hit something like, what the hell did I just do? Second mode to get to quit. Always brings you back to what I call the home screen, the calculation screen. Hopefully, if you haven't done a TI before, you've at least done a scientific calculator where as you throw stuff in, it actually shows you what you're plugging in, right? So that's 7 minus 8 squared plus 3. It knows order of operations. So it's going to do the square first and then do the rest of it, right? Okay, good, good, good. How are we doing so far? If I want to do the square root of 7 plus 5 and then add 2 to it, I'd have to close a parenthesis there first. So then I'm outside the square root symbol. You guys with me? So 7 plus 5 is inside the square root. I close that parenthesis. Now I'm outside the square root. Some of you guys have a brand new TI-8384 and your square root symbol just gets bigger and bigger. And then you hit the arrow button to get out of the square root symbol. I am jealous. I'm a math geek, so I love that the new TI-8384 is a lot more like the way you would write it on paper. It kicks a lot of ass. Instead of having this stupid little arrow, you guys just have it, it goes up, you can put an exponent, and then you hit the over button to come back down. For the newer, the rest of you guys, you're stuck with me with these stupid parentheses. That's just too bad for us. Okay, so that's some real basics. Where do you think is the button we're going to be living in most? Yeah, exactly. So right there, the stat button, almost right in the middle of the thing, stat. Hit that. And here you see you can sort, clear the list, set up editor, blah, blah, blah. The first thing is edit. And that's where I can put data in. So let's go ahead and hit that edit button. Please, dear God, anytime I do something on the calculator, we're going to do this a lot because we're going to do a lot of calculator stuff. If your calculator's freaking out, don't just go, well, just listen. Call me over. Let me know what the hell's going on. So when you go on to lists, some of you guys, if you borrowed it from me or if you borrowed it from somebody else, you might have all kinds of shit in here, right? Or is anybody missing L1 or L2 or L3? Is it missing or named something differently? Everybody's got it there? So if you got a bunch of stuff and you got 8 and 3.2 and who knows what the hell else, and you want it out of there, the quickest way to clear it is just to go up to the list. See the arrow buttons? Go up to L1 and hit clear. Enter. Now, if I go up to L1 and hit delete, what do you think is going to happen? L1 is gone. Too bad. The nice thing is, and this happens a lot, if you ever lose a list, go to Stat, number 5, Setup Editor, brings it back to normal. So hit number 5, enter. Now my list 1 is back. Thank God. How are we doing so far? Everything I'm saying is on that Calculator Bible, by the way. So now let's just take a minute. Here's the most exciting part of statistics. Data entry. So let's all enter the data from the histogram practice handout. So this is true data. I put myself in there too. This is true data from what I got from your responses to the survey for your height. I'll tell you honestly, I kind of rounded some of you guys that were decimal places just to make it easier for this histogram. Not 3,680. That's a tall dude. All right. And of course, you guys realize you're putting all of this into list 1. So thankfully, I'm not going to do a lot of problems where there's like 300 pieces of data, right? Because that's just silly. That's testing your ability to tolerate entering numbers into something until you go crazy. It's actually a good test for you to become a statistician. But everybody see this little number that's next to there? People freak out a little bit. Why is this okay? It says 44, but there's only supposed to be 43 pieces of data because I'm on a blank spot. So it's a good check. It really sucks when I say 43 pieces of data and you get the last one in is 42 and you're like, oh shit, which one did I miss? So trust me, that sucks. Also, I don't know if anybody realized, as I was typing it in, they made this very realistic. It has sticky buttons. So I put 66 and it came out as 6. So I got a 6-inch dude in here, or I put something in wrong. So watch out for mistakes. Kind of try to go through it real quick. I think everything in here is okay. If you hit down, you get back up to the top. Blah, 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 blah. Everything looks good. Yeah. All right, that's exciting. Okay. So what I want to do now is I want to sort this data. So the way you do that is you go back to stat. And what's the difference you think between these two sort options, sort A, sort D? Ascending, descending, right? So sort A would be from smallest to biggest, sort D would be from biggest to smallest. Let's do sort A. So you can either scroll down to number 2 or you can just hit the number 2 to pick something off a list. And see how it has a parenthesis, so it's waiting for input. It says sort what? And I want to sort list 1. And list 1 is right there in blue for me and yellow maybe for you guys. So you want to hit second 1. So now it says sort ascending list 1. Is everybody doing okay? If you hit enter, it's a little anticlimactic. Sorry, enter, done. So now if you go back into your list, stat, edit, now your list is all in order. Cool? Ooh, exciting. But trust me, I mean, when you have a big old list of data, being able to sort it is very useful, and sorting it by hand kind of sucks, right? Okay, so let's go back to, let's remember how to do this. I'm going to give you the, actually I already kind of gave you the steps. I'm going to give you the formula you need, and then I'm going to try to let you guys create your histogram. You've got your list of data sorted. You can do everything we did last time and this time to make this thing. Remind me, how do you get the class width? I like range divided by number of classes. Cool. Better notes you take, the easier it is to answer my questions like that. So it's up to you how many classes. How many classes do you think are you able to use? Between what and what?
5 and 10.
Between 5 to 10. Since this is a smaller set of data, you should use maybe 5 or 6. All right, so attack this problem. Do it. Call me over if you need some help. Work together if you want to.
At least 3.
Hmm? Oh, yeah, you got it. At least 5. Oh, so right here. Middletown. So that's one little evil place for me to take points on, but I won't do that. Do the wrong one? Careful what way. So how many, oh, the range is going to be how far your data goes. So what's the lowest your data goes? And what's the highest your data goes? I think it's 75 or 76. 76. So the range then will be how long that is. From 50 to 76, how far is that? Mm-hmm. And you just turn it around. So it should be 76 minus 50. It's always high minus low. Good. Now you get to pick your number of classes, and I'm just basically agreeing it should be either 5 or 6 classes. And now you divide them. Yeah. Remember, if you get a decimal, you always round it up all the way up. Oh yeah, you can always hit the second mode.
Okay.
That'll get you back to the home screen. Some I always forget where it is, but it's not here. Someplace you can hit the clear button, but here it would just clear that. The second quick gets you out of anything.
Okay, cool.
Where you at? Oh, hit second vote. That's the quick line. It always gets you back to normal. And you hit stat to get back into your. Oh, so now you just start counting from 50 to 54. I see 1. It's only the number 50 that goes up. 55 and 59. The number of times you see something that falls in that class. Oh,
you make your range where like
there's a single range, and your width has to be a constant.
okay.
So you can't have like one class wider than another.
Okay.
Because then I couldn't trust your. Yeah.
I asked that only because it's like, okay, well, it seems like, at least from that list, if I went to 50 to 55, it'd be one.
I've done my decimal table too. I was bad.
Oh, I see what you mean.
It'd be
That's the
better
kind of thing
knowing
you can't be worried
Add
about.
down from
Yeah,
the
because
regular
some
graph.
might end up being empty.
Yeah.
There's no way to really control for that. So what you do is you say, I'm going to highest list being 76. Yeah, 76%. Yeah, okay. And the lowest was a 50. So that's 26 apart. So you use 5 classes, 26 divided by 5 is a little over 5, so you round it up to 6. So I want a class width of 6. So you go from 50.
Yeah, and I know that.
So that's
So I chose 6 numbers.
chose 6 numbers.
So should I get more or?
Well, you chose 6 classes. That's that, yeah. All right. So the range, not the sum. That's more like an average. The range divided by the classes. So the range is how far it ranges from 50 up to 76. So how far does your data range? From 50 to 76, that's 26. So divide that by 6, yeah.
Yeah.
And remember, real quick, if you're doing it the book method, if you start at 50 and your class width is 6, you should go 50 to 55, remember? Because the quick way to do a class is don't even put this number yet. If my width is 6, I'm going to put the 56 there. And that's got to be 1 less. If your width is 5, I'm going to put the 55 there. And that's got to be 1 less. And then down, just keep going by. That's the trick to make sure you do it correctly, the book way. Some of you guys might be doing it the inequality way, which is a lot easier. Not that I'm biased.
Yeah.
How do you find out the frequencies on the calculator?
I'm sorry, say it. Oh, so now you go back to your list and now sort it so then you can just start counting. I only see one thing that you got. Exactly. So that's why we sorted those things.
So I'm gonna do like 6. Yeah. So just like the solution
Not 47, you move them down. What do you figure your width to be? Well, actually, 4 points, I think. So you always round up. If you round down, then you're not enough. Yeah, exactly. So 50 to 55. Yeah, that's good. 5, 6 is good. The last one though, don't ever base it on your data, base it on your distribution. Sort of like a scale, everything's got to have a place to fall. No, no. Good point. Now you just look back and say how frequently do you see something in between 50 and 54. Okay. Oh yeah, make it a percent. Here's a cool thing. Let me show you. You know from decimal percent, what is 25 Decimal percent. A little trick I'm going to show you. If you want to go from decimal to percent, you move the decimal back. So if you're at 0.5455, I want to move the decimal twice. Now you got to understand it's twice because it's per cent, per hundred. So it's 2 zeros. I want to move it once, twice. If I have a percent and I want to make it into a decimal, I got to move from there to there and move that twice. That's a quick way to do that. So I kind of skipped a little step there. I admit it. I didn't go to decimal. I went straight to percent. So I kind of moved it over twice as I was doing it. Oh yeah, now the reason we sorted the data was now you can say, where's your, from 50 to 54, how many data points do you see? I see just one data point, right? Just drop it. 55 to 59, I see 2. And keep going. You can make 13.2. Or 13.21 if you want to. They don't need to go that far. Is that an Android? Do you know if you have an Android phone, you can go to my website on there and download